I want to show you a memory device so that you can know all the function values of all the basic angles in quadrant 1, and from that, all the basic angles in all the quadrants. All you need to know is your left hand. Now, if you're left-handed and have to write with it, you have to count. Maybe you can sort of look at the back of your right hand, but I want to use my left hand. All right? And I have the standard angles drawn in quadrant 1. I have 0. These are all in radians. 0 radians, pi over 6 radians. You can think degrees all you want, but we're talking radians now. In fact, eventually it gets to be where you're thinking radians all the time anyway. Pi over 6, pi over 4, pi over 3, corresponding to 30 degrees, 45 degrees, 60 degrees. Remember, 30 degrees is pi over 6, 60 degrees is pi over 3. Remember, those are opposite. So I have 0 radians, pi over 6 radians, pi over 4 radians, pi over 3 radians, and then pi over 2 is the same thing as 90 degrees. 90. So, all right, think of this as 0 radians, pi over 6 radians, pi over 4 radians, pi over 3 radians, pi over 2 radians. All these values in quadrant 1 plus these on the axes. All you need to do is this. This is the memory device. This is never going to fail you. This will never fail. The denominators are always 2. Oops, let me make that a little bit clearer here. The denominators are always 2. Now, they might get simplified. I'll give you that. When they simplify, sometimes these denominators vanish. But start with denominator 2. And the nice thing is, once you have this in your mind, I have this in my mind, I don't write out the 2 in the denominator because I think it, simplify it in my mind, and just write the final result. All you need is this. Watch me. Here it is. Square root of 0, square root 1, square root 2, square root 3, square root 4. Remember to start with 0. Square root of the numerators are square root 0, square root 1, square root 2, square root 3, square root 4. That's it. For sine, these are the values for sine. Square root of 0, square root of 1, square root of 2, square root of 3, square root of 4. What is the square root of 0? You don't have to write it out. I mean, you can have a little bit more pride in yourself. What is the square root of 0? Square root of 0 is 0. And so this simplifies to simply give us 0. Sine of 0 is 0. Okay? Square root of 0, square root 1. What is the square root of 1? Well, yeah, you can write the square root of 1 if you want to, but that's awful heavy-handed. That's leaning a little bit too heavily on the memory device. Square root of 1 is 1. Sine of pi over 6 is 1/2. There it is. Square root of 2. Now, square root of 2 doesn't simplify, so you need it. Square root of 2 over 2. That is the value for sine of pi over 4. That's it. Square root of 2 over 2. Sine of pi over 3, square root of 0, square root 1, square root 2, square root 3 does not simplify. So see how this doesn't simplify, so leave it alone. This doesn't simplify, so leave it alone. This does simplify, so go ahead and write it as 0. This does simplify, go ahead and write it as 1/2. And then square root 0, square root 1, square root 2, square root 3, square root 4. What is the square root of 4? I think most of us know square root of 4 is 2. And so that's why we don't write it this way. We simply write 1. Sine of 0 is 0. Sine of pi over 2 is 1. We're going to get some stuff later on that's going to make memorizing this even easier than this, if you can imagine. But for these basic ones, that's how you can get sine. Sine is square root 0, square root 1, square root 2, square root 3, square root 4. Cosine, same numbers, other direction. That's all you need. Cosine is same numbers, other direction. Square root, so cosine of pi over 2. Let's make a new picture. Now, eventually, you don't Come on, guys, you don't need the picture because you can see it in your mind's eye. Trigonometry is a very visual subject. All right? Cosine of pi over 2 is going to be over 2. This is cosine of pi over 3, cosine pi over 4, cosine pi over 6, and cosine of 0. All right? Each of these is going to be over 2. And it's the same numbers, but they go in the opposite direction. Square root 0, which simplifies to give us simply 0. Square root 1, which is just 1/2. Square root 2 doesn't simplify. Square root 3 does. And square root 4 is 2, which simplifies to 1. So cosine is the same numbers, but the other direction. So sine, if you know this, then you just know cosine, same numbers, other directions. All right? So that will enable you to memorize those much more readily. You'll have it right here. You don't have to have a big, huge collection of things to memorize. It's square root 0, 1, 2, 3, and 4, and you'll have them. Always put them over 2 because they're always over 2. Now, a quick little argument. You don't necessarily need this. I want to show you why all this is correct. This is correct because we know that if a point lies on the unit circle, the sine is the y-coordinate. That point is 1, 0. So I know sine of 0 radians is the y-coordinate. It is 0. Same thing here. This point is 0, 1. Sine of a point on the unit circle, the sine value is the y-coordinate. The y-coordinate is 1. So those are easy. These come from the special triangles. If I put the special triangle in here, 30, 60, 90, here's pi over 6. This is, remember we have, this is 2, this is 1, this is square root 3. This is no longer the unit circle now. And so we have, if it's the unit circle, then we need to go with SOHCAHTOA. Sine of this angle, pi over 6, is opposite over hypotenuse. It's 1 over 2. And so sine of pi over 6 is 1/2. On the unit circle, sine of pi over 6 is 1/2. Similarly for this and similarly for this, it comes from these basic triangles. So that's where they come from. But once you have them, you don't need the basic triangles anymore. It's on your left hand. What sine of pi over 6 is square root of 1 over 2. What's the sine of pi over 3? Well, that's square root of 3 over 2, square root of 2 over 2, square root of 1 over 2, square root of 0 over 2, square root of 4 over 2. And so it's all here. And once you know that, then the rest of it will follow from it. And we'll go through the next video. What I'll do, I'll take this notion and expand it to the other quadrants, and we'll see how that works.